Hell,
No pressure.
dude, are we live on YouTube and Twitch?
I'm.
Do you see us on YouTube, dude?
See us on Twitch. Um,
We better be on YouTube too.
YouTube is live. We
Nice.
are live.
Okay. Awesome.
Sweet.
Sweet, 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 sweet. Well, welcome everyone to.
Yeah, thanks for waiting patiently.
Yeah, thank you. Um, just if you guys can, give us a comment just to make sure everything's working no matter where you're found. Um, and hopefully everything is going good for you. So,
Yeah,
alrighty.
let us know how beautiful Kip sounds.
Yeah. Um, and if not, all systems go. Sweet.
Awesome. Check that out. The comment comes
Yeah, it
up.
does, dude.
Nice.
Cool, cool, cool.
Okay.
Works for me.
Well, Kip, dude, I am excited for this class. I don't know about you, but I think it's pretty awesome.
Yeah, dude. Me too. And if you notice, the only two people that have commented so far are tied for second place. So
Oh,
that's pretty cool.
works for me.
Both work great. Awesome. Okay, well, should we get into it then, Jaden? Should we start explaining how this thing's gonna go down?
Yeah, so in this class, we are going to teach it in hopefully a fun and creative way. We're going to try and kind of theme it in the Dungeons and Dragons sort of way, where we have a character, we have obstacles to get through, we have health. You can see that at the bottom of our camera. And the camera is going to be our dungeon in this class. And we have to get through starting at the beginning of the camera to make the image, right, come through. And that's kind of our goal with the class. We'll be teaching physics and some math concepts along the way, and we hope you enjoy. And Kip, anything you want to add?
Yeah. So, like Jane said, this guy's is supposed to be lighthearted and fun, right? This isn't gonna be some, I don't know, boring school class kind of deal. So, to help you guys enjoy this more, we've turned it also into a game where you guys can compete against each other, right? And one of the best ways to do that is by having you talk to each other, right? So, how that's going to happen is you get 5 points for commenting to another viewer, right? Hello.
I feel like I should have more points than 100. Yeah. Well, start commenting and sharing and
Yeah.
stuff.
So you get 5 points for commenting to another viewer or talking, right? We're just sitting here, and then you get 7 points for answering a question. Okay. And then from there,
And that doesn't have to be a correct answer, right,
no,
Kip?
just for answering one of our questions that we posed to you. Okay.
Yeah, just wanted to
Yeah. Thanks for
clarify that.
clarifying. And then you'll also get 10 points for every relevant question, or for asking a relevant
You ask.
question, right? So if you ask a question,
Yeah.
you get 10 points. And I don't think asking where someone is a relevant question to what we're doing. And then you get 1 point for every minute that you've watched. So that's how each class is going to work to get you guys excited and motivated.
Right. And
And then,
you want to kind of explain the multipliers?
yeah,
You came up with those.
yeah. So if you guys subscribe either on Twitch or YouTube, you automatically have a 1.5 multiplier. So every point you get, it's going to be times 1.5. And then I still don't think that's a relevant question. And then from there, you get essentially every 2 weeks. So if you have a streak of watching for 2 weeks, you get a two times multiplier.
Winning, Kip. Yes, the answer is Kip.
Yeah, good job. And then from there, you also get, so if you guys like the video, okay, everyone watching gets a multiplier for that as well. So don't forget to like the video, and everyone that was watching that night gets an additional multiplier for that as well. And then we have some extra opportunities to, that's true, you cannot like a video on Twitch, but because you're watching, or because there's likes on YouTube, then you'll get that multiplier as well. Anyways, and then you can get some extra points during the week, okay? Where you can share a post on Facebook or Instagram, or tag a friend on Facebook or Instagram, and also by liking Aftermath Tutoring on Facebook or following Aftermath Tutoring on Instagram, okay? But guys, there's one last very, very important part in order to get points, and that is you must be signed up for the class, okay? So there is a link, I believe, on YouTube and Twitch where you can sign up for the class, and that's the only way we're going to be able to keep track of who has what points. Okay?
Right. So get on it.
Get on. Sign up for the class. Cool, cool. Alrighty, so ready to... Anyone got any questions about how you can make points?
Yeah, and if you don't really get the multipliers, that's okay. We have a spreadsheet that does it for us.
And we're smart with math, so we know how to do it.
Yeah, we can do it.
What's Twitch? Twitch is another live streaming platform. So, yeah. Alrighty, Jane, should we hop into it?
Let's do it.
Also, if you notice, your scores go across the top there so that, you can see every week where you're at. But those are only updated before each class, so they're not live updated. All right, Jaden. So, here we go.
Okay.
We're into Light's backstory. Dun dun dun.
So, right, generally in like a Dungeons and Dragons game, you are on your own making your character, and the dungeon master is creating the world and the story, right? He or she knows that there's points in the story that it might go left or might go right. Yeah, but they have plans for those situations. And we don't have it all set up right at the beginning, and the dungeon master usually doesn't. But Kip and I are going to be our dungeon masters for this class. Okay? And so that is where we begin. Light's backstory. We are kind of creating a character, Light. Okay? And Kip, I think that brings us to our first question. What do you think about that? What is light?
Yeah. What is light?
So this is a question that we want to ask. Just what is light for you. We have photons in the
Yeah,
comments. That's
that's
great.
great.
Uh, well, we just want to we want we want to hear what you all have to say. It's visible energy. It's pretty. Both a wave and not a wave. We have all these answers
Yeah, we
coming
do.
in.
We got
It is not darkness.
we got the
Cool.
opposite of dark. Cool. We got
Energy. Awesome.
awesome. Anyone else got
So this
some?
this question just want you to get thinking about what is light.
Yeah, because it's something, right, Jen, we use all the time, see all the time. Like, it's, I mean, it's
Yep.
how we see, right? Um,
Yeah.
and it's something,
If you're seeing anything, you're
yeah,
seeing light.
there's light, but like, what is that, right? Because,
Right.
it's like, I don't know, like, have you stopped to actually think about that? Like, how is something appearing in my eyeballs?
Right. It's cool. Yeah. It's all the colors around us, all the things you see.
We got the sun. We got a wave sometimes. Shaylee just turned on the light on her. Okay. So we've got a lot. We've got a wave, we got photons, we got all sorts of different things. So we got
Yeah.
light or visible light is electromagnetic radiation with a portion of the electromagnetic spectrum that can, I feel like that may have been copied from Google.
Maybe.
We've got radiation too. We've got the gospel.
A wavelength of sorts. Yeah. Bed. Sheesh. Oh, that's probably a comment to somebody else. Okay, but yeah.
4K.
So yeah, we just want to get you thinking
Yeah.
about it. Let's. Shall we go to before Maxwell?
Alrighty, dude. So, um, so before Maxwell, Jaden, right? So Maxwell is kind of going to be like our backstory character for this. All right, he's going to be the guy that's discovering light. So before him, everyone out there thought that things interacted mechanically. So what that
Okay,
means,
so what?
Jaden,
Yeah, what does that
is
mean?
that everything actually has to physically touch one another. Okay.
Okay.
What's his last name? His last name,
Maxwell is the last name.
Maxwell's last name. His last name is Maxwell. His first name is James.
It's James Clark
Yeah.
Maxwell. Silverhammer. That's awesome.
Okay, thanks for the questions though. Alrighty.
So right, like Kip was saying, is people thought everything had a touch to be able to move it, to interact with it, right? Uh, an interesting thing is they didn't totally understand how the sun was able to heat our planet at the beginning, right? They didn't understand what that was happening and how it was going on. So yeah, they're just who knows.
Yeah.
Let's just continue this mechanical stuff. We're doing good. We get to touch apples and eat them, whatnot. Okay. Uh, yeah, it's great.
That was great. So the idea being, right, that everyone thought that everything actually had to physically touch and interact with each other. But then all of a sudden, Maxwell and this other guy named Faraday came along. Okay, so
Right.
all of a sudden, Faraday started doing these experiments. Okay, with that's good. I'm glad you know him. But hopefully by the end of this, you'll understand the genius of Maxwell because he's probably like one of my favorite dead scientists out there. The guy is just a super genius.
He's up there with Newton and Einstein for sure.
Yeah, for sure. Um, and so it's really a shame actually that more people don't know him. But anyways, so Faraday he started playing with magnets. Okay, kind of like you do, or I still do. I play with magnets all the time. I love magnets. Um,
Right.
but during those experiments, he actually got. Who is your favorite that is alive? Ooh, mm, I don't. I only care about the dead ones. What's his name? I can't remember his name right now. The guy that just came out with his new book called The God Equation. Um, or whatever. That guy is pretty cool.
Oh, Mi- what it starts
Yeah,
with
it
an
starts
M,
with an
like
M.
Mikashu. He's pretty cool.
But anyways, so what Faraday did is he got some coils of wire, okay, and he started putting a magnet through the coil of wire. And as he did that, he had a way to measure the current going through the wire. And he found out that if he put the magnet through the current of wire without it even touching it, it created a magnetic, or it created current through the wire, right? So somehow things were not touching, and yet a current was forming. And he noticed, though, that if he just left the magnet in the coil, nothing happened, right? It was only when he was moving it that it would create a current through the wire, which all of a sudden got these guys thinking, right?
Right.
And so they came up with this idea of fields, this way of interacting, things interacting without them actually. That's the one, I think. Is that? No, I don't know.
Michio
Yeah,
Kaku.
that's him.
Yeah,
Yeah, yeah.
yeah.
I have not seen the clouds. I'm glad they have pretty light on them. But anyways, so we've got these fields that start forming, right? And to prove this, you can kind of see from this picture in the background there, but if you put a magnet on the ground, you'll get these field lines that start to form. They're invisible, but they're actually there, right?
Right. And this image that we have is iron filings with magnets,
Yeah.
right? It's forming this field that we see. It's going out of the north into the south pole of the magnet. Really quite cool. You can actually kind of see the magnetic field lines there. It's really cool.
Yeah.
Another interesting fact for everybody out there, Faraday called it a field because he liked thinking about it like a field trip for school, right? You go on this field trip, but you're still part of the school. So these field lines are still part of this magnet, right? But it's outside of it. It's really cool. But that's just an interesting kind of not a very useful fact, but it's kind of
So
fun.
there's a really good question that's out there that was called or that asked
So you guys can fact check me.
anyways, there's a really good question back a little bit ago that said um how do you know they're invisible? So maybe invisible isn't a good word, but they're things that aren't particles, right? They're interacting without anything actually touching, is a better thing. Okay, so
Yeah.
let's keep going. All right, Jaden, you're the math whiz. So
Oh, dude. Let's bring it, dude.
let's get into this. So Maxwell, right, was this theoretical physicist, and he wanted to figure out and mathematically describe what Faraday was figuring out. Okay?
Right. He they knew that something was happening. They knew that it wasn't mechanical interactions anymore, but things were still able to move and be altered from this moving a magnet through a wire. So he he did some really heavy math, and you can see it on the screen right now. Uh, there are only two equations on there, even though it looks like there's four. They're the top two, the white and the red. Those are actually the same equation, just in different forms. The white equations are integral forms. The red are differential forms. Uh, in certain situations, it's better to use one over the other. That's why they came up with two different forms. Uh, Kip, you were mentioning when we were making this lesson that this idea of two forms is a really cool thing to just show people that a lot of mathematics and physics is you can have a form of an equation and a different form. They can be the same thing, and you can also have a general form and make different equations for different things out of them, right?
Right.
You want to explain kind of what you were talking about when
Yeah.
you were telling me?
Well, so yeah, so one of the things that we can pull out of this, because we're not going to dive into the actual mathematics behind this,
Yeah, for sure.
because I mean, me and Jaden tried, and at one point in time, I think we both knew it pretty well, but it's a lot of really hard math to get done, and so what we've what we're going to do is we're just going to teach the concepts behind this, right? Um and so if we look at it, we're going to look at the left-hand side, or the right-hand side, I apologize. And we're going to look at
The
this.
right hand side of the equation.
Yeah, the right hand, so like the red equation, right?
Right.
So essentially that upside down triangle with that cross to an E, okay? That means that there's a changing electric field. All right?
Right.
Okay. And that's going to be related. And then you got this weird kind of, I don't know, I guess like a weird D, right? With a B divided by a weird DT. And from there, what we get is that means that this changing electric field is related to a changing magnetic field.
Okay. So a change in the magnetic field relates to the change in electric field and vice versa. Just looking at the bottom equation, right? If it's similar, we have a change in magnetic, change in electric. Okay, cool.
Are electric fields and magnetic fields the same thing? So no, they're not. And so this is where these ideas start to come into play here. All right. So what they discovered is if you had a current going through a wire, and that's a really good question. It's actually helping us explain better what Maxwell figured out, right? So they figured out that if there is a current going through a wire, all of a sudden there is a magnetic field that appears around it, right? So if there's
so on our image there, that's what those green lines are representing. There's this change in this field through a current in the wire.
right,
that's kind of what that image is showing.
yeah, exactly. So if there's a current going through a wire, that's going to create a magnetic field, right? And so
Right.
there's a distinguishing between electric fields and magnetic fields. And an electric field can be what's called a monopole, right? So you can either have a positive or negative charge. So if you have an electron, that's a negative charge, and that's going to create a negative field, right? And if you have a positive charge, then that's going to create a positive electric field. And so as you're
Right.
sitting there with these, let's say you have an electron just sitting there by itself, that creates an electric field. But there isn't a magnetic field at that moment, right? But as soon as that electron starts moving down a wire, say, it's electricity going through a wire, all of a sudden there's a magnetic field that is created from that moving electron, right? Because there's now a changing electric field.
And the same goes with if you have a magnet and you're moving that magnet through the wires, that's a change in the magnetic field, which causes an electric field. So,
is that because of friction?
Looking at these equations,
no one, to be 100% honest, no one knows what causes an electric field. No one knows like what actually these fields are, and that's one of the mysteries out there in the universe that is yet to be solved.
Yeah.
But all we know, scientists know, is that when you move an electron, it creates a magnetic field, right? Because maths.
Yeah. So looking at these equations, they look very confusing, and they are very confusing, especially for the untrained eye, right? But what we want everyone to know is this idea of a changing electric field causes a change in the magnetic field and vice versa.
Yeah.
Okay. That's the important part with these equations. There's a whole bunch of symbols in there that we could talk about for a long time and spend the rest of this course on, or we can leave it at that and learn some other cool things.
Yeah. So I'm going to leave you guys with a thought question right now, right? So if you have a changing electric field, and that creates a magnetic field, and a changing magnetic field creates an electric field, just kind of think about that for a second, right? Like what's going to happen if you have a changing electric field? Well, it's going to create a changing magnetic field. But what happens if you have a changing magnetic field? Ooh, what's that going to create? So just start thinking about that. Okay, yes. So we are ready to get into a black hole. So we are ready to get into our first challenge. Okay. So Maxwell's got a challenge going on here. And
all right.
Do you want to explain these rules,
we need to talk about rules. Yeah. So in our situation, the challenges are questions that we're asking. Some of them are going to be challenging. Some of them are going to be kind of freebie questions. But the question is going to act like the bad guy. Okay. So the bad guy is trying to stop light from getting through the camera and making a really beautiful picture. Okay. So the bad guy, they get to roll two 20-sided dice. Okay. And we subtract the max from the help if it was an easy question, or we subtract the min. Okay. That means if we roll 15 and a 10, and if it was an easy question, we subtract 15 from the help. Okay, that's the green bar at the bottom if anyone missed that. And the good guy also rolls two dice. Okay, the good guy, we are the good guys, right? Light is the good guy. If answered correctly by at least one student, we take away from the bad guy's roll. Okay, we use the max if the majority of the students are correct. So we use the highest number if the majority of the students are correct. And it can't be used if only one student answers a question, right? If one person answers it and they got it correct, then obviously that's the majority, but we want multiple people answering. Okay. And we use the min if the majority are wrong. Okay, so let's say the bad guy, it's an easy question, so we take the max of 15. And then let's say you all answer it and majority are correct. So we rolled a 13 as our max. We're only going to lose 2 health in that situation. Plus, we have this other cool rule. We add to the good guy's roll 1 for every right answer. Okay, so if 3 people got it right, we add 3 to that 13 roll, so we'd be at 16 and we wouldn't lose any health. Yay! Okay, and if everyone is correct, then we take the max of the bad guy's roll and add it to the health. Okay, so if everyone's correct, we don't lose any health at all. We actually gain health if we've lost health previous. Okay, and no good guy roll in that situation because there's no need.
Cool.
And obviously we'll do this multiple times, so we'll get used to it together. But those are the rules for the challenges.
Yeah. So, ready for the first challenge? And we'll explain it as we go here, okay? So, Maxwell noticed the similarities in the equations and wondered how the magnetic and electric fields are connected. So guys, we've got A, the change in magnetic field makes an electric field. The change in electric field makes a magnetic field. Or C, both A and B.
So go ahead, answer, type them in the chat.
You just need to put A, B, or C. And Jaden, what do you think it is, dude? Oh, we got 1 C. We got 2 C's.
We got a C.
Also, guys, please don't be scared to answer.
Oh, C.
Because if you do, like, if you answer wrong, it really is not much of a punishment. Okay, so there's like no punishment for answering wrong. We got a lot of C's, dude.
Yeah, we do. B.
We do. We have 1 B. Oh, 2 B's. We got 2 B's.
I changed my answer to C.
I think they did that because of peer pressure, maybe.
Maybe. Or they just jumped the guy.
I don't know. They didn't finish reading.
Okay, so,
oh, we got another C.
Okay, you wanna roll the dice, dude, for the good guys.
Can you see donations? Yes, I should be able to see them, but I'm not sure if they're showing up. Oh. Did it? Huh. It should be showing up. Thank you, Shaylee, for your donation. I appreciate that. I don't know why it didn't show up. I'll have to look into that, because it should. Oh, I know why. Hold on. Da-da-da!
Okay, so we have 1, 2, 3, 4, 5, 6, 7 C's.
There we go. Okay, so we got 7 C's. I think... Okay, so we're going to roll for the bad guys. Ready? Here we go.
Thanks, Shaylee. Shaylee.
Okay, so we got a 13. This was an easy question, right? So we're going to go with 13.
That's our max, yes.
Okay.
Okay, so we have 13.
And then we're going to roll for the good guys. Uh-oh. We got 8. Because the majority of you guys did get it right. The answer was C.
And then we add 7, so 15. So we don't lose any health.
Dude, we did it. Dude, is that math magical, dude, do you think?
Yeah, that was pretty good. So that is how our challenges are going to go from this point on. That was a good kind of freebie question, especially how much we emphasize the change in magnetic field and change in electric field. So it's all good. Uh, Now,
Wouldn't we still take 2 damage? No, because they had their high was 13. They rolled.
we rolled an 8 plus 7 is 15.
Yeah, we got a 15. They got the 13.
Yeah,
Yeah,
bad guy. Yeah, so we don't lose any health.
they got a
We're at
15.
100
Well, we
health
got a
right now.
15 too. So 15, 15. We're still good. We're safe
Yeah.
because we got a 15. Cool.
Okay.
Okay.
Our next
Wait, how would we
slide,
have
we
gotten a
have
13? Because, no, we got 8. See, we take the high number 8, and then we add it to the 7 people that got it right. So that's 15.
Yeah, who's arguing with
Dude,
us?
just annoying people. Are we going to learn about railguns?
Oh, that makes so much more sense. Yeah, you add the correct answers to.
Yeah.
We don't want to subtract the correct answers because that would be bad for people getting it right.
We are not going to learn
So
about railguns in this class, but maybe I can send you more information if you want to learn about them. Okay. Moving on. So now we got another question, Jaden. What is a wave?
Right. What is a wave?
Ooh. Jane, like this?
This is another. Hi.
Hi.
We're waving, right? This is a wave. So this is another thought-provoking question. We want to ask, what is a wave? What Kip and I were doing, that's a wave. There's waves in water. There's waves and things we can't see, right? We've probably heard of microwaves and radio waves.
Yeah.
A
movement.
Type in the comments, what is a
We've got
wave?
one. We've got a movement of energy. That's very good. I'd say that's pretty good.
I like that. Yeah.
I'd say that's pretty good.
Transfer of energy. Yeah, it's good stuff. The movement of it. Yes.
How some things move. Okay. Like water.
Like,
good.
yes. Waves on.
Yeah. A disturbance. Ooh, that's good. So there's lots of different types, or there's. Thank you for subscribing. I appreciate that.
Frequency. That's good. Hey, sweet.
Yes, energy. Well, yes, energy can move in other ways. But all right. So there's different types of wave out there. The two most important types are, I think they're called longitudinal waves.
Transversal.
So we've got longitudinal waves, and what's the other one, Jane? That's slipping my brain right now.
Transversal.
Transversal, something like that.
I think it is.
Transverse. I think it's just transverse or something. But yeah, so you got two different types of wave, okay? And the idea with movement of waves is that an object or the medium itself does not move, but the energy moves through it. So you guys are right when you're talking about this movement of energy, right? So an example of this is like an ocean wave. Just like that says in the latitudinal, maybe, I don't know. So the idea being that you have energy that's moving, right? A dance move. Yes, it is a dance move as well. Cowabunga. So when you have
transverse and longitudinal waves.
Longitudinal, right?
That's what it is.
Yeah. Okay.
Yep.
So in the course of like an ocean wave, the water itself actually isn't moving till it kind of gets to shore. But if you just see like a wave out in the ocean,
Yes.
you have just the energy's moving, right? And it displaces the water up a little bit, but the water itself does not move.
It doesn't go
Yeah,
forward.
it just stays in the same place, right? Another way to think of this is if you have a slinky and you just throw a slinky up, like if you're holding both ends and kind of like flick it, right? The slinky stays in the same spot, but the energy moves down it. And that's a transverse wave. And then a longitudinal wave is,
That's how you're hearing
yeah,
us.
that's a sound wave, right? So it's two particles will bounce into each other. It's kind of like pool ball, or yeah, like if you have billiard balls, right? You hit one ball, that ball stops, and the next one goes a little bit and hits the next one, and it causes that chain reaction. But the particle itself is barely moving. So what does that have to do with any of this, Jaden?
Well, if we go to the next slide,
Jaden, I see some more mathematical maths.
Yeah, this might even look more complicated than last. Who knows? But what we have here is a wave equation. Okay, so at the bottom, let's look at the bottom equation, everyone. This is a wave equation. It's just like the general format. You can see here we have velocity squared, so waves have to do something with the velocity. And then it's just a whole bunch of math symbols that it's not super important to this class. Okay, so we don't need to know what these partial derivatives are. You can look them up if you want, or you can just look up wave equations.
Right.
But that's what we have, and that's why it's very important, because Maxwell wrote this top equation down. Right, he was doing all
and
this.
This is only part of his equation, right? This is one part. It's actually 6 parts, so I just put down one of them.
Yeah. Yeah. There's a lot more mathematics into all this, but this equation, he's writing all these equations down. He was doing his, I don't know, I just imagine him like very focused, writing it all quick, and then he just has this realization, holy moly, I just wrote down an equation that looks very, very similar to this general wave equation. And that's what we have here.
Yeah.
Is a wave equation for an E and M wave. So it's kind of just amazing that he got to this point.
Right.
And realized, holy, I just found what this was.
Right. So he's sitting there, and how does it get an equation from that? So, yes, the GIF is really memorizing, and we're going to talk about that now. So, Maxwell, being the mathematical genius that he was, right, figured out these equations, and what he came to the consensus of is this idea that if you have a changing magnetic field, that's going to create a changing electric field. And then that changing electric field is now going to create a changing magnetic field, right? So all of a sudden, you have these piggybacking fields off each other that can literally just go through space, right? So all of a sudden, you have these things that are just piggybacking off each other. They're kind of like stepping over one another, right? So you have this.
That's what this GIF is showing, right?
So this GIF is showing that you have this changing electric field, which creates a changing magnetic field. And then you have a changing magnetic field, and that's creating a changing electric field. Well, that electric field's changing, so then it creates this changing magnetic field. And it just goes on.
And we could do this forever.
On and on forever, right? They're piggybacking off each other. And not only that, but when he did all the math, all of a sudden he realized something. That these equations that he was writing created a wave, right? So he found out that there was an electric wave field that was being created and a magnetic wave field that was being created, right? So there was this magnetic wave going through space. And along with that, there was an electric field that was perpendicular to that going through space. And they were just piggybacking off of each other, right? And
yeah. And Kip, tell what is like the most kind of insane thing about this.
so
He figured out, he stumbled upon,
yeah.
I guess. I don't know.
So he's sitting there and he figures out, and that's going to lead us to our next question here in a second, right? But if you notice, we have this 1 over v squared, right? So for this wave equation, you have a velocity. Was this guesswork at this point? How did he even figure this out? So there was some guesswork involved, and it actually, because of that guesswork and kind of just these mathematical theories that he had come up with, a lot of people at the time did not agree with what he was saying. But there was proof
Yeah, there
out
was
there.
a whole bunch of mathematicians at the time that were just like, no, he's
Yeah.
crazy, revolt, he's
But there
wrong.
was
And then there are
proof
people
out
that
there,
sided
right,
with him.
Jaden, that they had done experiments to prove that an electric field created a magnetic field. And they had done experiments that a magnetic field created an electric field. And so he was just playing with these, doing the math. And what you can see, though, is that this weird U and this weird E, which is a mu and an epsilon, which are Greek letters,
the ones with little zeros below them
right,
on the right hand side of the top equation.
yeah. So you have this weird U and this weird E, and if you, the thing you can do in math, if you have two equations that look the same, because of their properties, you can say that those two parts are equal to each other. And so in other words,
right,
this UE had to be equal to 1 over the velocity squared of this electromagnetic wave. Right? So, before we spoil it and tell you guys what that ended up equaling, we've got another question, challenge question for you guys. And this one involves a little bit of maths. So let's hop on over to our Jamboard, Jaden, just for the sake of it here.
Yes. It is.
So.
Slide 3.
So let's go ahead and make this pop up here. Where is it? Where?
Oh, we have a question. What is the difference between an electric field and a magnetic field?
So electric fields are created from electrons or protons or anything that has a positive or negative charge. Ultimately, that's what it will come down to. And then a magnetic field can only be made from moving electrons or protons, right? So it's actually a really interesting thing. Like if you have a magnet in your hand, there's no, you would think that there's no moving electrons in that, right? But how you get an actual magnet is in that material, there's essentially these little circles of moving electrons that are creating these magnetic fields. Okay.
Cool.
So we've got two answers for A so far. So if we remember, what I said is that 1 over v squared equals mu naught E. So we're trying to find out what V is. So we have two answers for A so far. But they may want to rethink that is all I'm going to say.
Yeah, you're solving for V.
Yes. So we want to solve for V. I mean C. There we go.
Yay.
Okay, so we've got one C.
Kelsey also.
Anyone else going to take a stab at it, or is you guys too scared? We got two people.
Yeah, two people answered this question. You can just guess.
Guess away. Remember, there's very little punishment for getting a wrong answer. We got another C. Awesome. So the more, just remember, you get points for your own score if you answer a question.
B.
We got a B. There's no C.
We got a couple B.
There's a C right here.
There's no C.
I'm confused. Okay, so we got two B's and we got two C's. Or three C's. Three C's to two B's.
Okay, let's roll the dice.
Dude, should we solve it first? Or should we roll the dice first? Oh, we got another C.
Oh, I guess we can solve it first.
What's M8?
Mate?
What?
What mate?
Oh.
I don't know.
What am I solving for then?
Together.
You're solving for this V right there.
He finds out the velocity of his E and M wave is... That's the question right there.
Hey, Preston, dude, thanks for hopping on.
Shaylee donated $1. Oh my gosh.
Shaylee donated another $1. Dude. Thanks, Shaylee. Appreciate it. We're getting rich, dude. We got another B. So are we got 4 B's.
Hey Kip. We got a hey
I know.
Kip. And another B.
We got another B. So I think are we 4 C's and 3 B's, or are we 4 and 4?
4 C's, 3 B's. That's what I'm counting.
So should we solve it first, or should we go ahead and roll the dice first? Oh, we got another C.
Guess we should.
What?
Guess we should probably solve it first.
Okay, so Jaden, what do we want to do first?
Dude, I'm gonna multiply by V squared.
Okay.
Multiply V squared. Then I'm dividing by mu naught epsilon naught. Phew! Divide by mu naught epsilon naught. And I get 1 over mu naught epsilon naught equals V squared. And how do we undo the squared?
Dude, we gotta take the square root of both sides.
Square root of both sides. So we get 1 because the square root of 1 is 1 over the square root of mu naught epsilon naught equals V.
Cool, dude.
Arrow like that because it doesn't.
So
okay.
Guess what, dude? That is solved. Ba-ching! And it is C. Hey, dude, I was swirling it. Okay, so let's go ahead then, and should we roll the dice?
Yes.
All right, dude. Ooh.
4B, 5C, 6C now. Okay. Did you roll them? What did we get?
We got 8 and 4. So is this a hard question, Jaden, or an easy question? Which one should we give them?
It was easy.
You think?
Yeah, probably. I don't know.
Okay, 8. So they got an 8.
Oh, dude, look at that snake in the chat.
Dude, we got an 18.
That thing is called PogChamp.
What?
Oh, and the good guys got 18. Whew.
So I think the good guys won, and we don't need to worry about anything.
Yeah, we don't need to add anything. Oh, good. We still haven't lost any
Dang,
health.
dude, we're doing real good. Okay, so
Okay.
why does this matter, guys? Well, let me tell you something. Ready? So that mu naught and epsilon naught are just constants, right? They're constants that show up when solving for other equations that have electricity and magnetism is in them. They were constants that people were able to solve for back then and had solved for. So they knew what mu naught was and they knew what epsilon naught was. These were just numbers. They also knew what the speed of light was. They were able to calculate it. And Jaden, guess what happened when he plugged in numbers into that 1 over square root of mu naught epsilon naught?
That equals the speed of light.
That it does. So he's sitting there, Maxwell sits there and he plugs in these numbers. I don't know what mu naught is. I know mu and mu 2. So mu naught is that weird U with that little O.
Yeah.
But, so Maxwell figured out the velocity of this electromagnetic wave that he had written out.
I know. Mu and mu 2.
He found out that that speed of that wave was the same speed as the speed of light. So Jaden.
So what you're telling me, Kip, is he found out the equation for light.
Jaden, he found out what light is. By just playing around with electricity and magnetism, right? He started out realizing that there was this connection between a changing magnetic wave and a changing electric wave, and figured out that they piggybacked off each other. And then he did some more math and found out that its velocity was the same as the velocity of light.
Right.
And if that's not like the most awe-inspiring, mind-boggling thing, then I don't know what is. Because to me, like, this is why he is my favorite dead physicist out there. Because, I mean, could you just imagine being him, right? Plugging in these numbers and being like,
yeah,
wait a second.
I just imagine he's like sitting under a candle writing these out, and he like does it, and then he probably just flips the table.
Like I just don't even know how to handle that. Anyways, it's been like this awe-inspiring thing to me of just the pure, I don't know how to explain it. But
yeah,
so guys,
I agree.
Another question for you. So what is light?
Now that we gone through all of these things, what is light? You can type in the chat. Let us know what you think light is now. We might have to like redo this lesson if we don't have. We have magnetic fields and electric fields, waves. If you're saying like a electric magnetic field wave.
Yeah. We've got
energy in a wave in electric and magnetic fields. Yeah.
I think you guys are on to something here. So anyways, kind of like field trips. Yeah, Jaden, kind of like field trips.
Supposedly. Yes. Well, I didn't fact check where I read that, but it made sense to me, so I said it out loud.
Okay, so that
It kind of makes sense.
is the end of our lesson thus far.
Right. So, what we want you to know, right? Light is an E and M wave. Electric and magnetic wave. That's what all light is. All the visible light that we see, all microwave, radio waves, infrared, ultraviolet, all of that, E and M waves.
No, this is not homework. So Jaden, yeah, you guys did really good.
Yeah, this is.
Health is still at 100.
Yeah.
So Jaden, do you want to go ahead now and kind of explain moving forward what this class is going to be like? Because tonight was like the first part of the backstory. We got a little more backstory going on, but you want to explain
Right.
our new Dungeons and Dragon character that we're going to be?
Right. So, as you all can see, our character through this quest, I guess, I don't know if you want to call it a quest or not, but let's call it that, is light. So our character is light. We have some abilities, characteristics. For example, our speed is 3 times 10 to the 8 meters per second. Our height is 0 to infinity. We were just kind of having fun with that one. And our weight is 0 pounds or 0 kilograms. Our race, so in this situation, it's going to be visible light. We'll talk more about visible light and other parts of light spectrum, but that's what we're just going to call it. Is our race is going to be our visible, right? The stuff we can see, the stuff we get through the camera, right, to make our images. We have refraction that unlocks at level 3. Virtual/real images, that is an ability that is unlocked at level 4. Diffraction unlocks at level 5. Reflection at level 6. And wave particle duality at level 7. So you might be wondering, what are these levels about, and like kind of what is this? This is essentially our syllabus, right? Each lesson is kind of like a level upgrade where we get new abilities, we get to talk about them and learn about them. But with kind of how we did this lesson, it was kind of freebie questions, right? Where we weren't really expecting to lose any health tonight. But there might be harder questions later on. There might still be freebie questions. But they're going to be questions that light has to go through. So it might be a question about a lens for the camera, or it might be an aperture question, or I don't know, I'm just saying stuff off the top of my head.
Yeah.
But just different questions about the camera and light.
Yeah, so
and yeah.
So each week we're going to be learning new characteristics about light, right? Light's going to have new abilities, and then we're going to need those abilities to get through the camera, right? Starting with the
Right.
lens. The first thing light's going to have to get through is the lens. And so light's going to need to level up to be able to get through the lens, and then they're going to need to get through
Right.
the aperture, they're going to need to get through a mirror, all sorts of things. And so every week you're going to be learning about how light works, but at the same time how a camera works. And it's going to be pretty awesome. So guys, thank you so much for watching. If you haven't already, go ahead and hit that like and subscribe button, because that could be very useful. Because remember, if we go back to slide number 1,
and hit the little bell so you know when we're going live.
Yeah, hit that little bell so you know we're going live. If you remember here, guys, here's your point setup. So every week that you watch in a row, you're going to get a multiplier. If you subscribe or follow, you get a multiplier. For liking this video, you get a multiplier. And yeah, don't forget to last comment so we know how long you've been watching for too. That's a good thing to add. That's important. And then also, guys, throughout the week, if you follow us on Facebook or Instagram, so if you go to Facebook Aftermath Tutoring or Instagram, thank you, Preston, for subscribing. I really appreciate that. If you go to our Facebook page and like us, or go to Instagram and follow us, you can get points for that, as well as tagging people in posts and sharing our posts throughout the week. You can get more points. Right now, Kelsey is still in the #1 spot and probably will be after this because she was commenting quite a bit. So, if you want to beat her this week, go post and tag like crazy. Thanks, Preston.
Yeah, thank you all for watching and participating. It makes it more enjoyable for us. And I hope you liked it too.
Yeah. And with that, we will say goodbye unless you have a question for us. And next week,
good night.
We'll be talking more about light. So there you go. And also, guys, the winner, whoever wins, will get a free t-shirt. And depending on how much you donate, you could also get a free t-shirt. So those are some incentives out there for you guys. But thank you and goodbye.